have John Gleeson from Storage presenting next.
Alrighty. So hello, I'm John Gleeson. I'm Chief Operating Officer for Storage Labs, and we are a distributed cloud storage provider. And I want to talk a little bit about some of the work we're doing here with Duroc in terms of storing data for scientific research and what some of the opportunities are where we can help you maybe some more. So at its heart, storage is just a distributed services platform. So we have a different approach to cloud. Most cloud providers build data centers, buy servers, rack hard drives, plug them into the internet and call that cloud. We find excess capacity all around the world, aggregate it and make it available as a low-cost, energy-efficient cloud storage platform. And we also took the software that we built for the most hostile environment possible, basically running it on strangers' infrastructure all around the world, and we're running that software on-premise currently at the University of Edinburgh in Durham, and expanding into Leicester and Cambridge this year. So we have two main components. We have our distributed storage. So this is S3 compatible object storage. So for anybody storing research data, this is a massively horizontally scalable storage platform. And it's basically your drop-in replacement for Amazon or anything else. We also have now added this year compute. So if you need GPU on demand, we have that as a service as well. It's really a different approach, and it's very privacy and security focused. So it's highly durable storage, globally consistent. Again, we have about 26,000 points of presence today between GPU and storage. And today we're storing across Leicester and Cambridge on-premise in addition to cloud storage. And with the addition, Cambridge and Leicester are coming soon, but with the addition of Leicester, we'll have an additional 0.5 petabyte of available capacity. And it's a really great option because with our public cloud offering, it's a very energy efficient way to store data that's still low cost and high performant. But the on-premise thing is really unique because we can find storage hardware that's out of service warranty, close to end of life, and extend the life of that infrastructure. The carbon footprint of cloud storage is really interesting. About 80% of the carbon footprint of hard drives comes from its manufacture, the mining of rare earth minerals, and that sort of thing. And you have a really sustainable option to extend the service life of hard drives when you use our software. Because you can run a drive instead of for 3 years or maybe 4, you can get 6 or 7 years out of it because you can run it till it drops. The software layer does all of the redundancy, all of the durability, all of the repair of the data that might be lost when a drive dies. And so it's really a great option to take things that are basically, you buy it with a grant, you use that hardware to the life of a program, but then at the end of it, you've got to find something to do with your data. You've got to find more protected storage capacity that you can't necessarily use that hardware for, and we provide the opportunity to take that hardware, extend its life, and make that capacity more available. So today, again, with the University of Edinburgh and Durham University, we're running our software. It basically captures underutilized resources on a couple of servers and a bunch of drives and makes those available as object storage. With Leicester and Cambridge coming soon and any other universities, it really just extends that capacity. So if you have excess hard drive capacity, if you've got an old NAS, an old SAN, an old Ceph cluster as part of your research, you should reach out. You can either reach out to me or Carl Mazurkiewicz on my team. Both of us are in the Duroc Slack. And also, you can reach out to Antonin Portelli. We can start to aggregate that capacity and make it available and make that capacity available to your teams. So a couple of new things this year. I mentioned compute. So we acquired 2 companies this year. One is a company called Valdi. They do on-demand GPU, and another one is QNOFS. QNOFS came out of Cambridge University, so it's 2 Cambridge PhDs, one in computer science and one in physics. And they built this file storage mount for S3 object storage. It makes it really easy to use object storage because you can just mount it as a drive on your computer or mount it as a drive in a container in an HPC environment and load data directly. It's an amazing kit. It's super fast. It came out of Cambridge, so you know it's good. But let me talk a little bit about Valdi because I heard a few people talk about the availability and access to GPU and I heard, if I could just get time on a couple of H100s, I'd be really happy. And one of the cool things about Valdi is they find excess GPUs in data centers all around the world as well. And these aren't just commodity, kind of garbage GPU. These are H100s, and just today we actually got H200s and GH200s. So pretty much any GPU you want, or if you want to take a bunch of different GPU and try your workloads on them and see which one is optimal for your particular model, this is a great way to try different things. And you can get them on demand, so you can just sign up and pick a GPU off the list and start using it instantly. Or if you have a project that's longer, you can reserve capacity and you can get access to bare metal for as many GPUs as you need. We have clusters with thousands of H100s in them where you can get access today, which is pretty cool. And again, QNOFS, you can go to QNOFS and you can just download the kit. They have academic licenses and they have free licenses for this. But it is amazing. It doesn't just work with Storage A, it works with any S3 backend, and it is incredibly fast. So if you want the easy button to interact with object storage, you can just install it, mount a drive, and go. And again, it works with on-premise as well, so if you've got storage, Minio, Dell, or whatever you've got sitting around, it will work with it. So I talked a little bit about our green story, but I really want to, sort of for this audience, I heard sustainability come up over and over and over again. And the couple of things that are really important at Storage A, one of them is sustainability. That's been one of our core focus areas since the beginning of the company, is to find these underutilized resources and maximize their service life to get a better energy solution for that. And also working in sort of the diversity, equity, and inclusion area, and making sure that not only are we taking a smart approach to generating storage, but we're also making it available more broadly. So in terms of how you can get access to this storage and how you can try it out, if you want to try either our cloud storage or on-premise, if you've got some research and you need someplace to put the data, reach out to Antonin Portelli. He's the administrator on all of the capacity. He can make capacity available to you to use. If you have excess capacity and you actually want to contribute that and make the broader storage bigger, please, by all means, take advantage of that. If you need access to GPUs, just go to valdi.a and sign up, and then find Carl or I. Carl, can you stand up for a quick second? Carl, yeah? So either Carl or I can get you some free credits. So if you just want to run some projects and stuff like that, we'll make it work. And then if you want to try Kuno, just go to kuno.io and download it. They've got an academic license that is awesome. And if you need an extension or anything like that, again, we're happy to help you out, or Antonin Portelli can. One last thing that I do want to talk about is just some of the extensions of the project that we've been doing here with the universities and with Dirac. One of the projects we have currently is searchable metadata for academic research. And this is a project idea that came from Antonin Portelli to sort of find a way to store ad hoc metadata. What research set belongs to who, for what topic, just ad hoc. And so we've been working on that, and we shared the specification for that with industry. So it's actually a company that does completely the opposite of academic research. It's a business where they have a mobile phone application that you can walk around a building, and it will take pictures of the walls. It will upload that data to a server, storing it on Storage A. It will process that data using GPU from Valdi and create a 3D rendering that's highly accurate and a floor plan. And so his business is going to some of the largest companies in the world that do factory floors, that do home estimations, and all of this stuff. And he saw that specification and was like, hey, I can go completely serverless with my whole application, changes the nature of my architecture, and moves my business forward by something that came out of the Dirac program. And I thought that was pretty cool, and that was something that, I told it to Mark, and he's like, hey, you should share that with the group, because it's great to see programs like this where industry and academia work together to bring these solutions more broadly to market. So that was an exciting thing that's going on now. And so we're delivering that specification through the end of this year, and then that business will immediately convert as soon as it's available in production. So that's pretty exciting. So that's a little bit about Storage A. That's what we're doing here with the Dirac program, and this is how you can get involved. Please let me know if you have any questions.
Do we have any questions?
there's a lot of talk about in AI systems coupling GPUs together very tightly. With the Valdi system, what's the closeness of the GPUs to each other?
So the interesting thing is you can sort of model that for what you need. So one of the trends that we're seeing right now is a pretty significant shift from model generation to inference. So most of the the market went and bought. I'm going to try to do that at least 3 more times. I'll just rotate slightly. Most of the market bought last year into huge GPUs for model generation, and that was basically it was a, if you had a big pile of GPU, then you were likely to get funding from somebody because you were going to do something great. And over the course of the last 12 months, what we've seen is a lot of open source models that are really good. And so it's very tough to compete with those models that have been generated by people who had way more money and way more access to resources, like Llama 3, for example. Why would you go build another one if you have access to that? That's just going to be another me too. And what this has resulted in is a little bit of a glut of GPU. And so now, if you want to do model generation, if you want to do some of these things either on a small or medium scale, it makes 0 sense to go and buy GPU, right? But so what do? There are now marketplace aggregators like Valdi through Storage that give you access to GPU, but you can get them pretty much in any sort of flavor and shape that you want. So if you need them in one place, you can find them. We have thousands of GPUs in dozens of locations all around the world. So if you want them in the UK, if you want them in Europe, if you want them in the US, you want a cluster of 8, 12, 16, 1,000. You want them for a month, a day, or a year. Our model makes it a really flexible way to consume that versus going to a hyperscaler, paying top dollar and being locked in for a year contract. And so in academia especially, where somebody may just want short-term access for a very small amount of money to go ramp up and get excess capacity because their local cluster is locked down or fully utilized, this is a great option for that expansion. And again, you can get all of your GPU localized in one location, or you can get it distributed where with the integration with storage, you can run a GPU workload, save state, wind it down, spin up a new cluster somewhere else because that one might be cheaper or closer to you, or a bigger or smaller cluster based on what you need. Pick up exactly where you left off because we've integrated both QNOFS and Storage to make that storage available as a persistent volume inside of those clusters. Long answer to a short question.
Yeah, cool. And what about things like NVLink? Is it possible to get GPUs connected with NVLink?
Yes.
I'm going to phone a friend.
Yeah.
Carl.
Good.
Yes. So yeah, we have NVLink enabled. We have InfiniBand across a lot of these clusters. So the cool thing about this, there's a couple of aspects. One is.
Thanks. There's a couple of aspects that are interesting. One is we've got this kind of on-demand capability where if you need an H100, a single card for an hour, or an L40S for an hour, you can do that. If you need a full node of 8 GPUs for an hour, you can do that. If you need a cluster of 8,000, I think our largest cluster might be 12,000 cards. And for 6 months, 12 months, you can do that as well. And there are variations of, do they have NVLink spines? Are they in the same data center? Are they in distributed data centers? One of the trends we're starting to see is that the AI workloads tend to be transient, right? So you'll go and you'll get some silicon for a week or 4 weeks. Pause your effort and already have something else in the supply chain lined up that's maybe lower rate, and you maybe move continents, frankly. You move your workload over there. So now your data is transient, moving toward the compute and following it. One of the things we're hoping to get the POC completed going into SC24 is we've talked about storage, we've talked about compute. There's a third leg of the stool, the network, right? So there's a very large North American network company that we're working with to do data access at the edge. So it's making high-speed interconnects available for AI workloads to push inference closer to the last mile. So there's a lot of stuff going on architecturally in the industry. So you'll have NVLink in the data center, you'll have IB in the data center, but we're starting to spread out across to the last mile, some of these high bandwidth technologies.
Cool, thanks.
So your point about extending the life of previous generation storage appliances is an interesting one. The constraint for some of us on that is data center space. So we tend to throw it out basically because when we stick the new performant one in, there isn't room for both that and the old one. Would you have a product that was based around reusing that kit, but within, you know, a data center that would be part of your services? I'm just thinking about, you know, refining that particular value prop where people are data center space constrained within local university storage.
Yeah, we have not explored that one yet because we don't actually run any data centers at all, right? And so what we would need to do is find a partner who would then like take that kit on. And you know, your point about sort of generational shift, right? There are nuances to it, right? It's not just anything because there is sort of that energy to terabyte ratio of, you know, right now nobody's running 4 terabyte drives except for like one place in Canterbury University that, okay, aces. But you know, just the right now, if you were to go and buy 8 terabyte drives, it's just not worth it because the energy consumption per terabyte is the thing that's going to get you.
Yeah.
But there's also the balance of you want a lot of drives because you get a lot of IOPS to spread across those. But for us, really, we're finding things in most universities, like somebody's got it plugged in somewhere, and it doesn't have to be high capacity, high volume, you know, petabyte level storage. 80% of our network is composed of nodes that are under 100 terabytes, and many of them are under 10.
This is the NAS in the corner of a postdoc room, kind of.
Correct. Yeah, and those really, honestly, make really good storage. We call them storage nodes. They're endpoints because when you have a highly distributed system like that, the number of things that have to go wrong to lose a large number of nodes gets pretty complicated, and so you get really good availability, and you're sort of distributing across those things. The storage software does some nice things around long tail mitigation, where even if you have slow nodes, it's totally okay because those slow nodes will store parity and they're not necessarily in the critical path for delivering key workloads. And so we get really high performance averaged across relatively slow nodes, which is kind of nice.
Thank you.
Mm-hmm.
All right, one last question.
Hi, you said in passing that your system is very secure, but obviously you're using lots of different facilities, lots of different sites, lots of different countries.
Yes.
So how do you guarantee that? Are you just dependent on the data centers that you pick, or are there additional layers that you provide?
So there are layers upon layers of security. So all of the data that's stored is AES 256 GCM encrypted with authenticated encryption with keys that are managed by our customers, not us, right? So encryption is the first layer of defense across the board. All data is also erasure coded, which means it's broken up into tiny pieces that are redundant, and they're distributed across the network. So any one node only has a tiny encrypted, erasure encoded piece of any object. So you can lose any node, and the availability, reliability, confidentiality of your data are not impacted at all. And similarly, no node can see access, or anyone who compromises 1, 10, 100 nodes is going to get anything usable out of it. So from like a security and privacy perspective, we have one of the largest hospital MSPs in the United States, storing data from 180 different hospital systems on our platform with high confidence. So like, it's good kit.
Great, thank you, John.
All right, thank you all very much.
Thank you, Storage, for your sponsorship as well.
Yeah. Remember, please come get your umbrellas so Carl and I don't have to take them home.